This will be normal contact, say N2. Then the weight of this will act. Its weight. Its weight will act. Then this normal contact is N1, and that N1 exactly opposite to that, I'll show it here. And the weight of this mg. The weight of this also will mg will act, and here also some normal contact. Okay, first we are giving the list of all the forces that will be acting. Now we'll give the name. So let this be N1. Similarly, an N1 force will also act here. Equivalent opposite here, normal contact will also come. Okay, if this is N1, this will be N1, this is mg, this is N2. This is m0g as usual weight, and this is N1. Okay, I think it's quite things very clear, no? This will move in this direction because N1 sin theta will act on it. How to describe the motion of this? So I'll describe their motion with respect to ground. They will have common acceleration along y-axis. Why they will have same acceleration? I think acceleration along common normal should be equal because this block C will be in contact with the wedge B. So the normal reaction, in fact, non-zero. So they must have same acceleration along common normal. Then because of this, okay, this will take N2. Yeah, I made changes here, and this will be acceleration AX. Now you can ask questions, sir, why this will not have horizontal acceleration? How the net force is acting vertically down? Here, component of N1 will act along positive x-axis. The resultant of weight N1 and the resultant of N2, the N2 mg and resultant of N1 will act vertically down. So therefore, it will have acceleration and N1 sin theta will be towards right. So let's describe the motion like this, and we'll write some equation. So we may get some help from this. So N1 sin theta is equal to max on the wedge A. This is. Similarly for the wedge B, N1 sin theta is equal to max. Then along y-axis, I'll continue further. Along y-axis, mg plus N1 minus N1 cos theta equal to ma1. Then on the block, these are the primary equations. So this will become m0g minus m2 equal to m0ay. Okay, the symbols. Let me add up these two. I think there'll be a better idea. Let me add up these two. Adding up these two. We'll make it one equation. m0 g minus n1 by root 2 equal to m plus m0 a1. So what I did is like, I'll call this as equation 3. Common acceleration along common normal must be equal. Acceleration along common normal must be equal because the block will be in contact with C.
Sir, for wedge A and B, sir.
For wedge C and B, that's what I wrote it, no? Block C, there's a wedge B, no? Okay.
Sir,
where all
same acceleration for wedge A and B, no, sir, along x-axis.
Yeah, definitely. Because what is the force acting? N1 sin theta on the wedge B, N1 sin theta on the wedge A. So I should put same acceleration.
Okay, sir.
Yeah, this is very important because we do think that because of block, okay, that one, let's not bother who is there on top of it. Net force on the wedge B, N1 sin theta, x-axis horizontally. Net force on the wedge horizontally, N1 sin theta, okay. So what is the thing? Assume that, so we are assuming that the wedge B and the block C are moving vertically with same acceleration AY. And the net force on the wedge B and the wedge A along x-axis is 0. So therefore, and the force is acting in one side, and so they will have same acceleration. I think this is some, I'll write that so that it will assume that. That wedge B and C will move vertically down now. Why we should assume? Because N2 is non-zero, so acceleration along common normal must be equal. Along acceleration along common normal must be equal. Okay, this is I think now for the wedge A and B, what is the thing you can write it? N sin theta, N sin theta. So there's no problem. That's why I wrote separately this one. Okay, we have this much here. Now what is a look, let's analyze what are the unknowns. What are the unknowns? You start counting unknowns. N1, N2, AX and AY. Am I right? AX, AY, N1 and N2. So we need more equations. So for that, again, the same idea. Now let me describe the motion of the wedge B relative to the wedge A. Motion of the wedge B relative to the wedge A. So I think we have to be a little bit careful here. I will go to the next set of the problem. I need only diagram. In the next set of the diagram, what we do is like, describe the motion of I will take it out all these things, so it will trouble you. No. So describe the motion of the wedge B along the incline or with respect to wedge A. Let that be AR. So as usual, this will be normal contact. And we know this will be acceleration, AX and AX. Then let's I think I need not to show all the forces, just you can know what are the N2 is here, no? I think it also will come into picture. What is the force that will act along the incline? mg sin theta plus N2 sin theta. And the forces acting perpendicular to incline? mg cos theta plus N2 cos. I think these are the things. If you stand on the wedge A, then you don't see relative motion between the wedge B and the wedge A. If you stand here, then you don't see any relative motion along this direction. I think this problem is very important. That's why I just picked up. Earlier, I was standing here. Then I said, okay, there is no, because these two are in contact. And because of that, acceleration along common normal should be equal. Now, what I'm going to say is that along this direction, acceleration should be equal. Provided you should know what is the acceleration of the wedge B and acceleration of the wedges. Then you can write here also constraint equation. But we don't know. All the unknowns are there. So therefore, I'll use other methods. So let's write the equation now. This will be the next part. Mg sine theta plus N2 sine theta. Pseudo force shall be applied. In what direction pseudo force should be towards right? I think pseudo force, we made a practice of showing it thick line. Thick arrow is what I used to follow every time. No, even the pseudo force component will also act. MAX cos theta equal to M into AR. It should be capital M plus M naught or only M. We are discussing only the motion of the wedge, not the wedge B and the block C. Only the motion of the wedge B. So this is the for the wedge B along the incline. And then perpendicular to incline, what are the forces? N1 plus MAX sine theta minus mg cos theta minus N2 cos theta equal to 0. This is for wedge B perpendicular to incline. Okay. This only will I think will simplify because theta, they know theta is 45 degrees. Then I'll write it. Okay, anyway, no, we'll further this one. This will become mg by root 2, N2 by root 2, MAX by root 2 equal to MAR. So this, if I write it in little bit systematic way, equation 4. This is N1 plus MAX by root 2 minus mg by root 2 minus N2 by root 2 equal to 0. Equation 4, equation 5. Still we are unable to do anything. Still we are unable to anything. Okay, let me do one thing. N1 by root 2, shall we write MAX, N1 sine theta or N1 sine theta equal to MAX? I think now let's see any help. I think complete description is available except question. See once, it's now only simplification. After this, only simplification. Putting that equation in this, putting this equation in that. One more, I'll show it. Put 1 in 5. Okay, I'll scroll down. I'll go for the next part of the problem. Root 2 N1. What is N1 is equal to? MAX by root 2. Shall we do one thing? Here, this equation will put it. N1 equal to how much will get it? Root 2 MAX. Already root 2 is there. Root 2 into root 2 will substitute. So put, after this, it's a pure simplification. I'll feel like. Now comes the calculation. One more equation is there. I'll show that. Okay, now we'll go for, I will retain this much here. Now put 1 in 2. Put 1 in 2. So what is the value? Root 2. This will become MAX sine theta minus MAX minus mg minus n2 equals 0. So it will become, I think, 2 max plus it is plus max minus mg minus n2 equals 0. So this will become 3 max n2 equal to 0. Call this equation 6. Now one more. Look at the motion of this one. What is the acceleration of the wedge B along x-axis? Shall we write any constraint equation? What is Ax? Come back. What is Ax here for the wedge B? Acceleration of the wedge B along x-axis with respect to ground. What is Ay? Acceleration of the wedge B along y-axis with respect to ground. What is Ax? Acceleration of the wedge A with respect to ground along x-axis. I think if I don't mention anything, it is understood it is there with respect to ground. Okay, let's write some equations here. So from here, acceleration of B, go back to relative motion, acceleration of B with respect to A along x-axis equal to ABX minus AX. What is ABX? Will be AR cos theta, towards right positive. Acceleration of the wedge. This is what AX. What is this? This is minus X. Hope everyone is able to understand. So many times you have come across this. So AR by root 2 is equal to 2X. I think there's a one very fundamental equation we are able to predict here. So now I think we are in better position. So what is AR by root 2 equal to? This is the equation 7 you write. Similarly, I want AY. Can we write AY with this help of this? That AR sin theta only is what AY, no? Acceleration of the block or acceleration of the wedge with respect to ground along y-axis. AR sin theta only. AR sin, sin theta is what AY. So I'll get relation between now AR and AY. So after this, what to do with all this one? We know AX. We know AX. Do we know AY? Yes, we know AY. Then what are the unknown things will come? N1 and N2. I think we have to get first expression for AR. If you get AR, then all our problems will solve. So what to do for AR? AR is here, no? AR is here. AY, what you can write it here? So all these equations are so many are there. Okay, this together we added up, no? So AY you can write it as AR will get in terms of N1. And next we have N1 also in terms of that one. So no, sir, I don't know N1. N1 again you have to going to bring here. N1 sin theta, what with that one? We should replace N1 into derive an entire expression for AR. I think you can manage. Now we have more equations than unknown. Anybody, value of AR? N1, what you write it as? AX by root 2. Substitute 1 in 3. Replace N1 in terms of AX. Then next step, what we do, AX will write in terms of AR. And AY in terms of AR. We'll solve for that, we'll get AR. So what shall I do now? Put 1 in 3. Put 1 in 3. Then 1, 7, 8 in 3. Equation 1, 7, 8 in 3. We'll solve for that, we'll get expression for AR. I will later on you check it. I'll I think that's everything. Let it come in order. Here only will wind up. Now what is our next part? Put 1, 7, 8 in 3. Okay, we'll proceed like this. Put 1, 7, 8 in 3. Solve for AR. So AR will be equal to, I already solved it. So I made it ready so that we can save time. Equal to 2 plus root 2. But still advisable, better you work out once. You know my maths that not that strong. This is the equation 9. Okay, once you get AR, I think you will get all the things, no? Now what you should do, substitute all that value of AR in the equation 7 and 8, you'll get AX and AY. I think that was the question that was asked to get the accelerations. I will write down acceleration AY is equal to it's very simple. After getting AR, okay, you do one thing, just substitute here, you get AY. Substitute here, you'll get AX. Okay, this will be AY equal to 2m plus m naught g by now what about AX? AX is very simple. AX equal to AR by 2 root 2. Again, we have to simplify it. Say same thing, it will come. It will be this will be m plus m naught g check calculation. 2 root 2 is there, no? Here. This will not be there. Okay, you see, these are the answers. Now you can find out these are things what he has asked. Now, a little bit lengthy, but I just wanted to give that acceleration along common normal will be equal. After class, you can verify nodes once. Very simple. So you need not to bother. See, why I brought this problem is like, we'll get scared. In a given problem, you can describe the motion of wedge B with respect to ground and also with respect to ground or also with respect to wedge A. The motion of the block B or the wedge B, you can describe with respect to ground and also with respect to wedge. We have another method. What is another method? We'll just assume that the acceleration of wedge B is somewhere in this direction. Acceleration of wedge A is like this. Then acceleration along common normal should be equal. Solve it, you'll get the answer. So 3 approaches is what you have. So whenever that block sliding on the wedge, no, let it be. You can manage. I'll go to the next question. Just send me, I think this will help you in WhatsApp. You just message. I'll send this one because all this will help you a lot in revising concepts. Other notes, everything is uploaded in app shortly. It will, by Sunday evening, everything will be available for you. All we discussed 1 week back also will be available.